Hello and welcome to another episode of Lost in Science for another week. It is 30 minutes, half an hour, whichever you prefer, of science on your radio. My name is Claire, and this week on the show we have, I think we have an interview and a story. Is that correct? Stu and Chris, I know you're there.
That is correct, Claire. I was speaking to someone this week. Have you ever seen the lists of endangered species in Australia for endangered animal species? You've come across these kind of lists which are put together by the federal governments and the state governments about which animals...
Yeah,
those lengthy lists.
Very lengthy list. We have a very bad track record.
We do, and a lot of, the lists of things that have gone beyond endangered is probably longer than we'd like them to be. But one of the things that's often missing from those lists is things that don't get, the cover of magazines very often, the things that aren't fluffy and cute.
Right.
I'm talking about insects in this case, invertebrates, which are very, very important parts of our ecosystems, but they don't seem to make the lists of critically endangered species. So therefore, people don't think about looking after them as much. So I am talking this week to Michael Braby, who is very heavily involved in figuring out which insects are endangered. And I'm talking to him about butterflies. And one of the reasons for that is they're really easy to spot, and also people like them. So it's an easy way to get people on board with looking out for insects and looking after insects as well. So I'll be talking to Michael later in the show.
Excellent. And Chris, anything else for us to get in a flap about, so to speak?
Well, I have a question first of all. What do toads and smartphones have in common? I think they're both invasive species that are devastating Australia, but no, what I'm talking about is both can possibly predict earthquakes.
What?
Well, okay, maybe that needs a bit of a asterisk afterwards. Like, maybe toads, some might be able to predict earthquakes.
And also, can smartphones really predict earthquakes?
Not so much predicting, but early warning of earthquakes.
Okay. But, you do mean more than just my phone rattling on the desk when there's an earthquake happening, right? There's something more to it than that.
Look, I will explain the technology, but that's a big part of it, actually, Stu. So, look, don't knock it. There's a team at Google has put a lot of money into it. They've got a new initiative that is using the accelerometers on Android phones to detect earthquakes. So, it is based on the same technology that makes your phone rattle on your desk. So don't knock it, Stu, until you've tried it.
Certainly don't knock it off the desk.
Well, butterflies and earthquake predictions this week on the show.
The acceleration of endangered species in Australia and around the world is a great concern to ecologists and environmental scientists. But legislation to protect many species is not in place in Australia, either at a state or a federal level. And this is especially true of insects and other invertebrates. And with us on the show this week, we have Associate Professor Michael Braby, who is currently a visiting scientist at the Australian National Insect Collection in the ACT. And I've got him here to talk to us about why insects have been possibly overlooked in classification and protection of endangered species, and possibly what we can do about it. Welcome to Lost in Science, Michael.
Yeah, good afternoon or good evening. Thank you.
I guess the first question people might have is, why is it important for things like insects to be protected by environmental legislation?
Yeah, that's a good question. I just pick up a point you made earlier about the few numbers of species that are actually protected. And I guess that really stems from two issues. One is that we're dealing with a really huge fauna, a vast number of species. Some people refer to the invertebrates as the other 99%. That is, of all the animal biodiversity out there, insects and other invertebrates make up 99% of all the species. So it's a huge portion of the pie. So that's one issue. Another issue is that many of the species are undescribed. So I think in Australia, we estimate that we've documented about 40% of all the insects across Australia. So many species do not have scientific names. So we refer to that as the taxonomic impediment. And I guess the third issue is that there are not many ecologists or conservation biologists actually actively working in this space. There's not many people devoting their careers and their time to insect conservation. It's a really sort of not a particularly glamorous field to go into, and there's just really not many people in that space. If you think of conservation broadly across the biota, the majority of people work on the charismatic animals like the birds, the mammals, I guess plants to some extent. So they get the lion's shares of all the conservation resources. So and it's quite sad because if you think about the importance of invertebrates, and just to pick up your second question, and that is that they really are the backbone, or they are the fundamental building blocks to our whole entire ecosystem. So all of our vertebrates, all the big other animals depend ultimately on somewhere in the food chain on insects.
I guess it is ironic that the spineless animals are the backbone of the ecology. It is interesting that you say that 40% of insect species, invertebrate species, are unidentified or don't have a taxonomic place. It makes it very difficult then to conserve those species if we don't even know that they're there, really.
Yeah, we may know them at one level, but from a legislation level, where they really demand an actual scientific name, it makes it quite difficult. So for some species, we'll have what we call working names. So we'll call it genus A, species X or something, or it might even have a genus name to which it's provisionally placed. But so that's why I guess a lot of the conservation attention is thrown on things like butterflies, because there aren't that many species in Australia. We're talking 400 odd species versus, I'd hate to think, but tens of thousands of species for some of the other groups. And most of the species have scientific, or probably all the species have scientific names. There aren't that too many species that don't have a scientific name. So they're quite an easy group to work with. And also they act as really good ambassadors for the conservation of other groups. So we know that, for example, if the butterflies aren't doing well in some location or in a particular habitat, you can guarantee that there'll be another 10 or 100 species of other insects that are in the same fate.
And as far as butterflies go, if we only have a few hundred species of Australian butterflies, are there actually invasive butterflies as well?
We have a couple of species that I guess reach pest status. The most notable one would be the cabbage white. That was a butterfly that was introduced from Europe, and that really causes a few issues in the horticultural industries because it attacks vegetable crops, and maybe a bit of an issue in people's gardens in suburbia. But apart from that, the only other species that really, I guess, are not warranted would be, or not part of the native fauna, would be the monarch. But that's a pretty harmless species. That was a species that got across here from the United States in the late 1800s. It basically stepped across via the Pacific Ocean. And that was because we established its food plant. It breeds on a plant not native to Australia, but we established those plants in people's gardens. So it had a ready food supply for its caterpillars. And once it got here, it was able to breed. But it's a fairly benign species and quite a spectacular species. So I think most people would be quite happy to have monarchs in their garden. The other one I should mention is a species called the tawny costa. It's a species that came into Australia about 10 years ago, and it's now established and it's spreading quite dramatically. As far as we can tell, it doesn't seem to be invasive in the sense that it's having an impact on our native biodiversity. But it's a species that was native to Southeast Asia, particularly India and Sri Lanka. And over the last 30 years, it's been steadily moving through Southeast Asia, and it got into Northern Australia in 2012, and it's now spread right across Northern Australia and into southern Queensland. I have heard there are records in eastern New South Wales. So that's a very interesting example of an invasive species, but it's not necessarily having an impact as far as we can tell.
So it's not none of these are displacing Australian butterflies. They're just moving into territory that's been vacated for other reasons.
We think so, yeah.
Sorry,
Oh,
sorry, I was just going to follow up saying, is that because of the feeding habits of these butterfly species? They seem to feed on particular food plants in their juvenile stages, and they don't compete for food in that way. Is that basically the reason why they're not being displaced?
yeah, that's right. So that's that's definitely the case for the cabbage white and also the monarch. The monarch feeds on swamp plants, amongst other things, in the genus Asclepias. The tawny cross is an interesting one. It actually feeds on a native violet called Hybanthus, which is also eaten by one of our native butterflies called the glasswing. But the tawny costa also feeds on an introduced vine called Passiflora foetida. There's a number of Passifloras in Australia. Most of them are weeds that have come in from, well, actually, we think they've come in from Asia, but most of them are native to South America. And so feeding on those plants, they don't really have any impact on our native species.
So that's I guess that's one good thing. So the work that you have been a part of with butterflies particularly is identifying Australian butterfly species that are at risk of extinction. What is driving that endangerment of those species?
Yeah, that's right, Stuart. So we have looked at what species we thought might be at risk. That's really the first step in identifying or trying to save species from extinction, is actually to know which ones are actually in trouble. The last study was done 20 years ago, 2002. The Australian government funded a study which culminated in a very substantial report that was done by Tim New and Don Sands. And so there really hasn't been much done since then. So I think in that report, they identified it, they thought at least 10 species were threatened nationally. So we thought it was about time we should update that. So we did this a little bit differently. We actually held a workshop where we got a lot of experts around the nation together to basically discuss and debate which species we thought might be in trouble. And that was the first part, and then to identify the species that we thought would be facing imminent extinction, that is in the next 20 years. And so we identified 26 species that we thought were in fairly serious trouble. And of those, five of those 26 species, we estimated that we've had a high likelihood of facing extinction in the next 2 decades. The threatening process that came out of that study, and that coming back to your first question, was that there were was multifaceted. There were many factors that were at play, but the big one was habitat loss and the fragmentation of those habitats. That seems to be an issue across many species. And we have to remember that we have cleared in this country about 75% of the arable land in the southeast and the southwest. And while that's brought enormous prosperity and wealth to this nation, it's actually come at a really high cost. And one of those costs or losses is the loss of biodiversity, and butterflies are really no exception to that. So that was really number one, the loss of habitats. A second big one was an interesting one. It was actually was a disturbance issue related to fires. We've had some very catastrophic fires, as you may well recall from last season. But one of the issues we've identified is actually in some areas is lack of fire or lack of disturbance. So possibly a lack of traditional burning regimes in some areas where the habitats become long unburnt. Not saying long unburnt habitats is a bad thing, but in some very specific cases, it can actually lead to vegetation encroachment, which can change the whole floristics and vegetation dynamics, which is quite detrimental for some butterflies.
So is that linked back to the food plants again of those butterflies? They don't have the food source for the new generations.
Yeah, that's exactly right. So butterflies are intimately dependent on particular suites of plants. Usually they're very specialized species of plants. And if you lose those species, and that can happen through vegetation change, then that'll have flow-on consequences to the butterflies. The flip side of that is too much burning. So we've seen examples where in the landscape where the fire frequency has either been too high, or there's been periods of no burning, and then you get these catastrophic fires. So we've caused enormous changes to the burning regimes. I'm not a fire ecologist, but just looking at the butterflies, we're seeing a lot of species disappearing or populations dropping out, and we suspect that's related to changed fire regimes. We have a lot of issues with particularly grassy weeds in some habitats. They are not only displacing the native plants on which the butterflies depend, but they're also changing the fire regimes. So we've got issues, particularly in Northern Australia and Central Australia, with grassy weeds adding to the fuel loads.
As far as clearing land and that sort of thing goes, and people owning properties in various areas, is there anything people can do as individuals that would help to protect those populations in any way?
Yeah, I think it's really important. Many of the species and populations of species occur on private lands or they're on roadside verges. So it's really important that the landholders don't clear those little remnants of wood vegetation. I was just up in the Darling Downs last month with my honours student, and we were just astounded by the fragmentation and the amount of land that's being cleared for agriculture. Now, that's, like I said, that's brought enormous prosperity to this nation. But we're now in a situation where we just have these tiny little fragments left. And it's really important that those areas are managed and looked after and not cleared any further. And sometimes they're on roadside verges. And so there are ways of protecting those little patches. But the other thing that I touched on fragmentation. That's a really big issue because a lot of the populations of these species occur in little pockets over the landscape. And once you start to lose the interconnections between those populations, they're basically on a trajectory towards population decline, and that can lead to defaunation or extinction. And so it's really important that those areas are connected by corridors and maybe patches of bushland on roadside verges, or it could be farmers or landholders planting small patches of vegetation to enable species to connect, be able to disperse between those connections.
And obviously this applies across the whole country. It's not the same species of butterflies in Victoria and New South Wales and Queensland and Western Australia. They're all different species in different places that need different habitat plants to survive.
Yeah, that's very true. So most of the species we identified had very small distributions, and in fact, we identified a couple of areas that seem to have a concentration or a hotspot, if you like, of many species. So one of those was in southeastern Queensland and northeastern New South Wales. That seemed to have a high proportion of threatened species than any other part in the country. And when you break it down and look at those species, they're all got different requirements. So the 3 or 4 species that really came up on the top of that list were the laced fritillary. That's a butterfly that occurs on the eastern coast in the coastal lowlands. Its caterpillars depend on a little native violet. Some other species with the bull oak jewel. That's a butterfly that depends on old growth bull oaks, Allocasterina lumanii. And it also depends on an ant. There's a very specialized ant that occurs in those habitats. So it needs the co-occurrence of the ant plus the bull oak. And there's another butterfly in that habitat called the sapphire azure. The southern population of that species is also in serious trouble. That only occurs in the bull oaks, but it depends on a mistletoe that grows in the bull oaks, and it also needs the same ant. So they're very complex ecological interactions that need to be maintained.
It certainly is starting to sound like just maybe we need to leave as much intact as we can and improve the bits we've got, because that fragmentation is obviously leading to big problems with those populations of the plants and the ants and the butterflies all together.
Yeah, I think we're trying to. I mean, it's a hard message to get across. I think we've come to this country 200. We've been here for 250 odd years, and we've had this approach of just going forth and multiplying and clearing, and I think it's sort of ingrained into our psyche. And I suspect a lot of people don't really realise what biodiversity assets we have in our back garden or in our doorstep. And so one of the things we really need to do is increase the awareness and the information of these species. And I think if people knew how beautiful some of these species are, they would probably not clear those little pockets of land and really try and look after them. So that's really, I guess, number one is to try and look after those little bits of land to the left, those little pockets of vegetation, trying to reduce the weeds, try to increase the connectivity between these pockets. So they're all things that people can do, the community can get on board. But might just jump back a step. It's one of the things we don't have for many of these species is that not many of them are protected under national legislation. So I think we identified only 6 of those 26 actually have formal listing under the EPBC Act, the Environmental Protection Biodiversity Conservation Act. That's really the legal framework on which you can then do conservation actions on some of these threatened species. So we need to get more of those species protected under that act. And then the next thing would follow on from that would be to then develop a recovery plan or a conservation advice. That's essentially a document that basically articulates or sets out the recovery actions required to stop those species from a trajectory towards extinction. So essentially, basically, it identifies the stakeholders who'd be involved in the recovery. It might be local councils, government agencies, it could be NGOs, conservation groups, local landholders, and any community groups. So those are the people who would come together to look after a particular species. And there's some work actually happening in that space. So it's not all doom and gloom. There are a few species that have actually very advanced recovery groups, teams working on some of those species. The other things that an action plan or recovery plan articulates is it identifies the threats. And we don't always know what the threats or the drivers are leading a species to extinction. In some cases we have pretty good ideas, but in some cases we don't. We just know that they're declining. So it'll try and identify those, and if you don't know, it'll set out a roadmap for future research or monitoring that needs to be done. Usually those documents also try to estimate a cost, what will actually cost the community to save those species from extinction. So that would be step 2, to develop a recovery plan following formal listing under the legislation. The third thing that then needs to be done is to actually implement the findings of those documents. And that's where the recovery team really would come into play to then implement those conservation actions or management actions.
Well, it's a good thing that finally someone's looking into this area, and like you said, 20 years is a long time to leave something like that, especially with the continued population increase in Australia and the continued land clearing and that sort of thing. It is good that someone's at least starting to record and figuring out what is actually in danger, so that if people are concerned, they have somewhere to sort of throw their support, I suppose.
Yeah, that's true. And a really good example was the Richmond birdwing. That was a butterfly 20, 30 years ago. We were really concerned that was on the brink of extinction. But due to a massive community campaign in the Brisbane area and northeastern New South Wales, that involved schools and a whole lot of community and engagement. And they actually have got that butterfly. It's now at the stage where we consider it to be rehabilitated. It's I guess we call it conservation dependent. There's been so much planting of its native food plant, which is a vine that grows in the subtropical rainforests of southeastern Queensland and northeastern New South Wales. And that's a butterfly that's now done really well. So you can actually turn things around if there's a lot of community goodwill and a passion to stop these things from going extinct. I think our next big challenge would be to tackle something like the laced fritillary or the Australian fritillary. That's a butterfly that's found in similar latitude. It's basically in the subtropical zone of southeastern Queensland and northeastern New South Wales. That's a butterfly we're really quite concerned. There's only been about one observation in the last 20 years. So it's possible it's gone. We hope it hasn't. We hope it's hanging there somewhere, still hanging there somewhere. It occurs in basically coastal lowland swamplands. It's been heavily impacted by urbanisation, and as you mentioned earlier, population growth. It's had a really big impact on that species. But it's a species we don't know a lot about. We don't know entirely. We don't have a really good understanding of its ecology, so there needs to be some serious research on that butterfly. It's a really fantastic, it's a gorgeous looking species. It'd be a real shame to lose that one. And there is a group up in northeastern New South Wales at Coffs Harbour. The New South Wales government does actually have a threatened species officer that is currently investigating that species. So we're really hoping that some really good stuff will come out of that.
And I guess on top of that, we can save the attractive butterflies and hope that they, the attention that they get will also save other species which may not be those poster child species, that they'll get saved alongside them as well.
Yeah, that's very true, Stuart. So we use the term, we call that an umbrella species. So butterflies are often considered to be umbrella species in conservation biology. And that means that essentially by conserving that species and its habitat and its food plant and its whole ecologies, you save all the other species of invertebrates that are tied to that particular ecological community. So it's a really good, butterflies actually perform a really good role in as ambassadors or as umbrellas in terms of conserving all the other insects in that entire ecosystem.
Can you tell me about your app that you've got to help identify the distribution of these butterflies?
So late 2019, a postdoc and myself, we just released a citizen science app for the general public to upload observations on butterflies specifically. You can download that app onto your mobile phone. And there's also a web portal or a database on the internet. If you type Butterflies Australia, those two words on your internet, that'll take you directly to the database. And that's across all butterflies, not just the threatened ones. We can handle all 440 odd species across the nation. And we have a team of experts in each state who do the moderation. If you don't know what the species is, don't worry. The moderators are there to help you.
We're going to run out of time in a minute, so I would like to thank you, Michael Braby, for joining us on Lost in Science this week. Really interesting work you're doing, and hopefully we can get some of these butterflies' trajectories turned around.
Terrific. Thank you very much for the opportunity.
Across Australia on the Community Radio Network, you're listening to Lost in Science.
Back in 2009, a 6.3 magnitude earthquake struck the central Italian city of L'Aquila, killing over 300 people. As a result of this earthquake, 6 scientists and a government official were sentenced to jail for failing to warn people about the earthquake, although they were later cleared of charges. It took about 7 years, I think, for them to be cleared of charges. But this was very controversial amongst the scientific community because basically it's considered impossible to predict earthquakes, and so a bit rough for people to be convicted for not doing so.
It sort of seems like a bit like blaming the meteorologists when it rains. It's not really their fault that it rains. They are just there to try and predict it, and they don't always get it right.
Yeah, look, there is a bit more to it than that, for that particular event. But the heart of it, that it is impossible to predict earthquakes, is one of the conundrums here. So, because earthquakes, as you probably know, they usually happen when there is like movement along fault lines in the Earth's crust. And basically, you get this tension, the energy builds up at these sort of fracture points, and then eventually it is released suddenly, and that causes waves to spread throughout the surrounding ground, earth, if you like, and quaking it, hence the name. Now, clearly, these are very damaging. It would be great to be able to predict when the release will happen, but so far, actually working out when that break will happen doesn't seem to be possible. It doesn't stop people speculating, though, and looking for ways to predict, which is kind of the thing that led to the problems in L'Aquila. Because there was a technician at the nearby physics laboratory called Gran Sasso. This is also famously the same laboratory that measured the faster-than-light neutrinos, which turned out not to be faster than light. Completely unrelated. Got
to get a bit of physics in there, though.
It's just an interesting kind of coincidence. But yeah, this technician, Gianpaolo Giuliani, had been monitoring radon emitted from cracks in the rocks. The theory is that, from him and a few other people, is that when there is about to be an earthquake, there'll be cracking in the rocks that will release radon gas. Yes?
Question.
Yeah.
I I didn't know that radon was coming out of the Earth's crust when there's earthquakes. That's a sort of cool fact.
Look, it is. It's not. This is not a reliable way of, not regarded as a reliable way though of predicting earthquakes. Otherwise, we would be doing it all the time.
Right.
There are a few things like this that kind of are sometimes associated with earthquakes, but not always. So they're not a reliable predictor. And sometimes earthquakes happen without these things. Because one of the reasons is because earthquakes can happen at various depths in the ground as well, and so you don't know whether it's going to be close enough to the surface for these kind of things to happen. But yeah, this guy had been detecting this radon levels increasing. There had also been a bunch of small tremors. So he was basically going around telling everyone there was going to be a big earthquake. But at the time, the scientists' view was that the small tremors were actually releasing some of the tension in the fault lines, and so making a bigger quake less likely. And it was their efforts to calm panic before the quake that were then blamed for some of the deaths. So they're saying people would have been prepared if they had have been, allowed to be warned. Whereas the scientists were saying, no, we don't think there's going to be an earthquake. So it's a bit subtle, but yeah, it is still basically asking them to predict the impossible. And as I said, the radon theory is not an accepted thing, and we still don't really know enough to basically say whether you can or cannot reliably predict earthquakes. But there are other indications that there can be, in these cases, some changes in the rocks. Interestingly, there was something else that happened at the time. There was behavioural ecologist Rachel Grant and her team were monitoring a colony of common toads. That's the species Bufo, and there was mating season, and suddenly all the male toads just up and left. Now, they've been doing this study for about 4 years, and this hadn't happened. And their first thought was, well, there's our research project gone. But then the earthquake happened a couple of days later, and when the shaking was over, the toads returned.
Are these toads that can detect radon?
Well, one of the theories is, again, that is something else happening in the rocks. There's suggestions there could be changes in groundwater levels, or perhaps there are electric charges being created that cause hydrogen peroxide to be created in the water. But it's not really known what the mechanism is. And again, there's all these kind of theories that there could be something happening, but they're not reliable predictors of earthquakes, unfortunately.
Also, it could have been a coincidence.
It could have been a coincidence. It seems there's a lot of stories, folklore over the centuries of animals predicting earthquakes. This is one of the more reliable kind of reports of it. But again, it could have been a coincidence.
Are any of those animals toads, or is this the first time we've heard of toads being some sort of sage-like creature?
Look, I'll be honest with you, Claire. I don't think toads are magic, but I could be wrong on that one. I believe they're one of the 4 magical animals permitted in Harry Potter if you go to Hogwarts, but that's the extent of my knowledge of the genre. But look, it's one of those things where if there was a reliable method, then people would be using it, because it's not like. Otherwise, you have to resort to a conspiracy theory that someone is trying to want there to be quakes and ignoring these possible signs. Truth is, we don't have a reliable way of predicting them. So a more reliable method is to actually detect when there is an early sign of an earthquake and then warn people about it. And this is where the Google smartphones come in. So this is based on a system called Shake Alert, which was developed in California. And what they had was a network of seismometers. And essentially, Google partnered with them initially to be able to send alerts when they detected signs of an earthquake to people's phones. Now, the idea here is this sounds like you're just telling them that, hey, it's shaking, when people already know about it. However, the idea is that the signals to phones travel pretty fast. They travel at the speed of light, essentially, whereas seismic waves that transmit the earthquakes from its epicenter, they move fast as well, up to 5,000 meters per second, but they're a lot slower than the phone signals. And so the idea is that if you can give even, a very short amount of warning to people, they can take cover and protect themselves if they know a quake is on the way. Google has been running this kind of alert system. They actually have it available. They say you can search earthquake near me to see the latest seismic activity near you. I tried that. Maybe there's nothing near us, or maybe it's not activated here. But if you actually just search earthquake on Google, you'll get basically a list of the latest earthquakes that they've detected with their systems. So this was how it started. But the Shake Alert system with all these seismometers was pretty expensive to create and to maintain. But then they realized that there is already a network of effective seismometers out there, which is the smartphones, because modern smartphones have an accelerometer that detects movement, used for various purposes, but it is something that can detect when there is some kind of shaking. Now, there is, of course, a lot of different kind of shaking that can happen. The early testing did lead to some false alarms. So they were testing this in the United States. Now, what happens, there's these things called Amber Alerts when there's a missing or abducted child and it causes a phone to vibrate, and those were sending off false alarms about earthquakes. And also sometimes thunderstorms would cause a lot of shaking that would then lead to false reports. So they've kind of improved the algorithms. And they believe they have a fairly reliable detector of earthquakes. And of course, they don't rely on just one phone. They lean about, 100 phones to confirm that there is a report, which then they put into the system and then send a message to those who are likely to be vulnerable to this quake. So recently they have, in the last couple of weeks, they've announced that they have released this system outside the United States. They've released it in Greece and New Zealand. 2 countries that are prone to earthquakes, and they're pretty confident that it will be able to make a difference there. They've tested it on some of the data from a quake that was in in Greece, and that they reckon they could have predicted if the system had been operational. So yeah, they're pretty happy about this. Of course, there is some reason for skepticism, as you can imagine. Like particularly in New Zealand, where there probably is not as many people sort of in the rural areas as required to with their Android smartphones turned on. And it's not going to do things like warn you about a tsunami, because tsunamis are caused by an undersea earthquake, and there aren't enough phones in the ocean really to detect these undersea quakes. Also, I haven't been able to find any information about how the software is actually activated onto people's phones. They talked about downloading it in a standard system update and talked about having 2 billion active users, Android users around the world to run it with. So, I don't know, it just sounds like another way that they are basically monitoring all your phone's activity. Which sounds a little bit creepy, I guess. But I suppose if they're trying to use it to save lives, it's probably a bit better than, I don't know, tracking you to sell you things that they sell you, like mattresses or ties or something that they track across the internet. But anyway, so look, it is interesting use of technology, and it is kind of an interesting application that is using something that's already out there and trying to solve a problem that, apart from the toads, we don't really seem to have much of a handle on.
That's all we've got time for this week, and we are rapidly running out of time. If you want to get in touch with us, you can email us. You can find us on Twitter and Facebook. We are broadcast across Australia on the Community Radio Network with the financial assistance of the Community Broadcasting Foundation. And if you would like to tune in next week, Chris, Stu, and Claire will get
Locked in
Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.